Hello everyone, today we are going to discuss the problem building roads from CSES graph problem set. So let's see the problem. Byteland has n cities and m roads between them. The goal is to construct new roads so that there is a route between any two cities. Your task is to find the minimum number of roads required and also determine which roads should be built. So input contains two integers n and m, the number of cities and roads. The cities are numbered 1 to n. And after that, there are m lines describing the roads. Each line has two integers a and b that tells that there is a road between those cities a and b. A road always connects two different cities and there is at most one road between any two cities. So this is the input given. So first line contains an integer. You have to print an integer k, that is the number of required roads so that every city is reachable from every other city. And then you have to print k lines that describes the new road, and you can print any valid solution. Okay. The constraints, if you look, the number of cities can go up till 10 power 5 and the number of roads can go up till 2 into 10 power 5. And cities are numbered from 1 to n. Okay, cool. So let's first of all try to understand what the problem is, and then we can see how we can actually solve this problem. Okay. So let's suppose you have 7 cities. Okay. City 1, city 2. City 1 and 2 are connected to each other. Then you have city 3, city 4, city 5. Again 4 and 5 are connected. 3 and 4 are connected. And then you have city 6, city 7. 7 and 2 are connected to each other. Let's suppose you have 7 cities like this. Now, if I ask you, tell me which roads should I build so that every city is reachable to every other city. For example, currently if you look from city 1, can you reach to city 6? From city 1, can you reach to city 6? No, right? Because there is no road to reach from city 1 to city 6. From city 1, can you reach to city 7? Definitely yes. If you follow this particular path, then from city 1 you can reach to city 7. From city 1, can you reach to city 4? No, right? There is no path between city 1 and 4. From 3, can you reach to 4? Yes, there is a path between 3 and 4. So you have to say that you have to connect roads so that every city is reachable from every other city, right? This is what the problem statement is, right? Okay. So for example, in this statement, if you connect, let's suppose city 1 and 6, and let's suppose you connect 2 and 4. If you do this, then can you say that every city is reachable from every other city? Can you say that? Let's check. From 1, can you go to 4? Yes. From 1 to 2 you can go, and from 2 you can go to 4. From 1, can you go to 6? Yes, there is a direct connection. From 7, can you go to 6? Yes. From 7 to 2, 2 to 1, and then 1 to 6. From 5, can you go to 2? Yes. From 5 to 4, and then 4 to 2. So if you build these two roads, then you can go from any city to any other city. So for this example, we can output that number of roads to be built is 2, and you are building roads between 1 and 6 and 2 and 4. So this is what the problem statement is. I hope the problem is clear to each and every one of you. Cool. So how we can actually solve this? So if you just notice, I will proceed with this particular example only. If you just notice, let's suppose we haven't built the road still now. Okay. So this road is not there. This road is not there. Okay. So if you see city 1, 2 and 7, between city 1, 2 and 7, you can select any start city and any end city and cover the path, right? You start from 1, end at 7, start at 2, end at 1. Anything you do, you can reach between them. So can I say that I have city 1, city 2 and city 7 that are all reachable among each other, right? Similarly, if you look, there is city 3, 4 and 5 that are reachable from each other, right? City 3, 4 and 5 they are reachable from each other. And you have city 6 separately. From city 6, you can't cover any other city, right? Now tell me one thing. If I want any of these cities, if I want any of these cities to be reached from any of these cities, is it enough to construct only one road between any city of this particular component and any city of this particular component? Can I say this? For example, if I connect a road between, let's suppose, city 2 and 3, if I connect a road between city 2 and 3, then can I say these two components will get merged? That is, now city 1, 2, 7, 3, 4, 5 are reachable among each other. You can select any start city and any end city within them and they will be reachable. Can I say this? Right, yes. And yeah, you can construct more than one roads as well, but constructing one road is enough, right? You can reach any city to any other city if you just connect one road between any city of this component and any city of this component, right? So now once you do that, now you have this component, this and this got merged, and you have another component, this one. Now what you will do? Of this component you will select a city, of this component you will select a city and merge them. And once you do that, so you will get a very big component in which every city is reachable to every other city. So this is what you need to do. So now the question comes down to constructing these components. If I am able to construct or separate out these components, my job will be done, right? So how we can actually do that? Let's see. So let's consider the above example only, where we have city 1 connected to city 2, connected to city 7. Then we have city 3 connected to city 4, connected to city 5, and city 6 is standalone, right? Cool. So what we can do? We will simply do a DFS traversal. How? We will first of all start from 1, okay? Let's suppose we maintain a visited vector. So what we will do is we will maintain a visited vector where indexes will be index 0, 1, 2, 3, 4, 5, 6, 7. And initially all values are 0. This implies that I haven't visited any of these cities yet. Okay. Now what will I do? I will start DFS traversal from city 1. And I will see what all cities I can reach from city 1. So since I start my DFS traversal from 1, I will mark 1 as visited. So this is marked as visited. City 2 is marked, then from 1 you can visit 2, so 2 will be marked as visited. And from 2 you can visit 7, so 7 will be marked as visited. So these 3 cities will be marked as visited. And since I started my traversal from 1, what I will do is I will store 1 somewhere. Let's suppose I have another vector. Over there, I will store simply 1. Okay. Over there, I will simply store 1. Cool. Now, I will move from 1, I will move on to 2. I will see 2 is already visited, will do nothing. Then I will move on to 3. 3 is not visited. So from 3, again, I will do a DFS traversal. So, will mark 3 as visited. From 3, I can go to 4, will mark 4 as visited. From 4, I will go to 5, I will mark 5 as visited. Every city in this particular component is covered. And since I started my DFS traversal from 3, I will store 3 in some vector where I stored 1. Now I will go to 4. 4 is already visited, will do nothing. We'll go to 5. 5 is already visited, will do nothing. We'll go to 6. 6 is not visited. So first of all, I will store 6. And from 6, I will do a DFS traversal. So we'll mark this as visited. And there is no other city to cover in this DFS traversal. So we'll do nothing. And you can see every city is visited now, right? Now see the magic. You have 1, 3, and 6, which are nothing but cities from this component, and this component. Are you able to notice that? I have one of the cities from this component, one of the cities from this component, one of the cities from this component. So what I will tell now that I have three different components. Now tell me one thing. If you have three different components, how many roads you need? You need two roads, right? And you can connect them in any way you want. You can connect 1 to 3, 1 to 6. You can connect 3 to 6 and 3 to 1. You can do anything you want. What I am doing in the code, in my code is, I am connecting 1 to 3 and I am connecting 3 to 6. I am building roads between 1 and 3. I am building roads between 3 and 6. And this is how we are reaching to this solution. So this question was nothing but, first of all, you need to identify that, okay, you can separate out in different components. And then of different components, you just need one city. And if you connect one city of one component to the one city of the other component, the entire component gets merged. You can even solve it via disjoint set union by separating out the components, but you won't need that, as you can also simply do that by a simple DFS traversal, as we have covered over here. So let's see the code for better understanding. So this is the code. First of all, I am taking inputs of n and m. N is the number of cities and m is the number of roads we have. Then we have constructed edges of size n plus 1 since the input is given in one based indexing format. Then we take the inputs of road. You are given a and b. So in my edges of a, I simply pushed back b, and in my edges of b, I simply pushed back a. So this is how I construct an adjacency vector, right? Then I constructed a visited vector, which tells that whether I have visited a city or not. And again, I am keeping its size as n plus 1 because we have one based indexing format and initializing the value with false. Then constructed a vector int answer. This answer will basically store these things, one city from every component. Okay. So traversing over every city, and if that city is not visited, so in my answer, pushing back that particular city, because the component that we will cover from this city, for that I am pushing this particular city, I, and simply making a DFS traversal from this particular city. So again, I am using a lambda function for this, and since it is a recursive lambda function, I also need to pass the name of the function over here. It's very much similar to normal function, just because I don't need to pass this edges and all, so I am using a simple lambda function. The return type is simply void, because what this DFS traversal is doing, it is simply marking all the cities that are reachable as visited. So first of all, I am marking the current city as visited, and then I am traversing over all the child cities. And if the child city is not visited, I am simply doing a traversal, DFS traversal from that child city. Once I am done with this, and let's suppose t is the size of the answer vector. So how many rows do I need to build? T minus 1, right? Like for example, over here, the size of the answer vector will be 3. So you need to build in total 2 routes. So printing 2 and then traversing from 0 till t minus 1 and printing whatever is the answer of I and answer of I plus 1. Like for example, over here, we will be printing 1, 3 and then 3, 6. These are the 2 roads that we are building. And if you understand this, we are good to go. If we talk of time complexity, you can simply see that we are going to each and every city exactly once. So if let's suppose n is the number of cities, so the time complexity for this particular problem will be big O of n, right? Okay. So I hope you all understood the solution. Thank you.